Moving on to example 3, again, we're going to find the partial fraction decomposition. So what we're going to do, we can actually factor the bottom. This is going to be a repeated linear factor. I can take an x out, I'll be left with x squared minus 4x plus 4, which you then can factor to x minus 2 quantity squared. So that means it's to be written as a over x plus b over x minus 2 plus c over x minus 2 squared. Now this is where it gets a little different. That means negative x squared plus 2x plus 4 will equal a times x minus 2 quantity squared plus b times x minus 2 plus c times x. Now the way I do that, if you look at your first fraction here, a over x, it's missing the x minus 2 quantity squared. B is missing the x and another x minus 2. C is only missing the x. That's how I knew what to multiply there. So we're going to simplify this. We'll have a times x squared minus 4x plus 4 plus bx squared minus 2bx plus cx. Simplifying a little bit further and distributing the a in, we'll have ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. Now we're going to collect our like terms. We can put a plus b times x squared plus a negative 4a minus 2b plus cx plus 4a. Now what's nice about doing it this way, we know that a plus b is equal to negative 1. I don't know why I put negative 2 there. A negative 4a minus 2b plus c is equal to 2, and 4a is equal to 4. So what we can do here, you can see from that last equation that a is equal to 1. That means 1 plus b is equal to negative 1, which means b is equal to negative 2. And since you have that, negative 4 times 1 minus 2 times negative 2 plus c is equal to 2. Negative 4 plus 4 plus c is equal to 2, which means c is equal to 2. Putting this into our partial fraction decomposition, we'll have 1 over x plus negative 2 over x minus 2 plus 2 over x minus 2 squared. Now again, putting this into our calculator, we'll have a negative x squared plus 2x plus 4 divided by x to the third minus 4x squared plus 4x. Now that's going to equal 1 divided by x plus negative 2 divided by x minus 2 plus 2 divided by x minus 2 squared. Now I put the x minus 2 squared in parentheses again so it knows I'm squaring the x minus 2, not the entire problem. So when you graph this, you will see that it's the exact same function. If you don't get the same exact graph, then you did something incorrectly. Now, I told you in a previous video that there was another way to do this, and you can actually do it using matrices. So what we're going to have to do here, we're going to have to create a matrix, and I'm only going to show you this once, because it's really not too useful, but in your homework you'll have to do it. A plus B is 1, or is equal to negative 1. So I have 1, 1. Since there is no C here, we'll put a 0, negative 1. We'll use the second equation here. Negative 4, negative 2, 1, 2. And we'll use this third equation. 4, 0, 0, 4. So here's your matrix you can create. Now to create a matrix again, go to your matrix. We're going to edit. This is a 3 by 4 matrix. Enter your matrix in. So now we have our matrix. Now, if we go into and make it a reduced row echelon form of this matrix, you'll get the same answer in reduced row echelon form, where A is 1, B is negative 2, C is 2. Okay? So the reduced row echelon form is there. So you can do it using reduced row echelon form. Now you can also do it using inverse matrices, where A times X equals B. So we can have it 1, 1, 0, negative 4, negative 2, 1, 4, 0, 0, times matrix X, which is ABC, and that will equal negative 1, 2, 4. Now again, we're going to have to change our matrices just a little bit. This will be a 3 by 3 now, which does change a little bit. We will have a 3 by 1, and that will be negative 1, 2, 4. Now a couple things we do need to do again. We need to find the determinant of matrix A. Determinant of matrix A is 4, so that means A inverse does exist. So we take matrix A inverse times matrix B, and you do get the same exact answer. So it's another way you can do it using inverse matrices. You will have to do one on your homework using inverse matrices. You will have to do one using reduced row echelon form, but again, you can do that in calculators. Now, for example B, we can factor out an x, be left with x squared minus 2x plus 1, which again will factor the x minus 1 quantity squared, which means this will be a over x plus b over x minus 1 plus c over x minus 1 quantity squared. Now, the a over x term, or fraction, is missing x minus 1 quantity squared, so x squared minus x plus 2 is actually missing, so we'll have that, plus b times x minus 1 plus c times x. So what we'll have a times x squared minus 2x plus 1 plus bx squared minus bx plus dx. Simplifying this a little bit further, we'll have ax squared minus 2ax plus a plus bx squared minus bx plus dx. Now, collecting my like terms, I'll have a plus b x squared plus a negative 2a minus b plus cx plus a. Which means then a plus b will equal 1. Negative 2a minus b plus c is equal to negative 1. And a is equal to 2. So what we can do there, that means 2 plus b is equal to 1, which means b will equal negative 1. Then we can have negative 2 times 2 minus the negative 1 plus c equals negative 1. So negative 4 plus 1 is negative 3 plus c equals negative 1, which means c will actually equal 2. So once we have that, A, B, and C in, we can actually write it into our partial fraction decomposition. So 2 over x plus a negative 1 over x minus 1 plus 2 over x minus 1 squared. Putting this into your calculator, so I have 2 divided by x plus a negative 1 divided by x minus 1 plus 2 divided by x minus 1 squared. And there you have it, same exact equation. Now in examples 4 and 5, they're going to be irreducible quadratic factors. That'll be in the next video.